When you get in your car to go on a drive, you often look at your gas gauge, which is a type of a level sensor. Industries use several different types of level sensors to detect their products. Today, we are going to talk about the different types of level sensors used in the industry. Level sensors can be broken into two classifications: point level measurement and continuous level measuring. Point level measurement indicates when a product is present at a certain point, and continuous level measuring indicates the continuous level of a product as it rises and falls. The sensors for point level indication are capacitance, optical, conductivity, vibrating or tuning fork, and float switch. The sensors for continuous level measuring are ultrasonic and radar or microwave. We will talk about how they work and which applications are best suited for their technology, as well as their limitations in certain applications. Let's talk about point level indication sensors first, starting with capacitance level sensors. A capacitance sensor is a proximity sensor that gives off an electrical field and detects a level by the effect on its electrical field. These sensors are small, less expensive than other sensors, invasive to the product, accurate, and have no moving parts. However, they do have to be calibrated and will only detect certain liquids. Capacitance sensors can be used in liquid storage tanks. A water treatment facility that has storage tanks would be an ideal use for a capacitance sensor. The next point level sensor we will talk about is an optical level sensor. Optical sensors work by converting light rays into electrical signals, which measure a physical quantity of light, then translate it into a measurement. These sensors have no moving parts. They are not affected by high pressure or temperature, are small in size, and can be used in liquid applications. However, if the lens gets coated or dirty, they would require cleaning. They can be used as low-level indicators to prevent run-dry conditions when using oil, coolant, or hydraulics. Another style of point-level sensor is conductivity or resistance. A conductivity or resistance sensor uses a probe to read conductivity. The probe has a pair of electrodes and applies alternating current to them. When a liquid covers the probe, its electrodes form a part on an electric circuit, causing current to flow, which signals a high or low level. The advantages of using a conductivity level sensor are there are no moving parts, they are low cost, and fairly easy to use. The disadvantages are they are invasive, meaning they must touch the product being sensed, they only sense conductive liquids, and the probe will erode over time. Appropriate use for these sensors would be for signaling high or low levels. Vibrating or tuning forks is another type of point level sensor. They use a fork-shaped sensing element with two tines. The fork vibrates at its natural resonant frequency. As the level changes, the frequency of the fork will change, detecting the level. These sensors are cost-effective and are also compact. They are invasive to the product, meaning they have to touch the material to sense the level. These sensors are easy to install and are essentially maintenance-free. They have unlimited uses based on the material that they can sense. Mining, food and beverage, and chemical processing industries use these sensors for their applications. The last point level sensor that we will talk about is a float switch. Float switches use a float, a device that will raise or lower when a product is applied or removed, which will open or close a circuit as the level raises or lowers, moving the float. The advantages of a float switch are that it is a non-powered device, it provides a direct indication, and they are inexpensive. The disadvantages are they are invasive to the product, they have moving parts, and can be large in size. Float switches will only give an indication for a high or low level. They cannot measure a variable level. A great use for float switches is in liquid storage tanks for high or low level indication. Now, let's talk about continuous level measurement sensors. We will start with ultrasonic sensors. They work by emitting and receiving ultrasonic waves. The time it takes for the waves to reflect back is how distance is measured. These sensors have no moving parts, are compact, and reliable. The disadvantage of using this type of sensor is that they can be expensive, and in some situations, the environment can have a negative effect on them. The benefits of ultrasonic sensors are that they are non-invasive or non-contact. They are unaffected by the properties of the material they are sensing, and they are self-cleaning because of the vibrations they give off. An example application is a hot asphalt tank in a shingle manufacturing plant. The ultrasonic sensor would be placed in the top of the tank, away from the hot asphalt, and used to sense the level in order to send a fill request for the tank. Radar, or microwave, is also a continuous level sensor. These sensors transmit microwaves by an antenna on the radar sensor. The product that's being sensed reflects these microwaves back to the antenna, and the time from emission to reception of the signal is proportional to the level of the product. Radar sensors are not affected by temperature, pressure, or dust. They can also measure liquids, pastes, powders, and solids. They are very accurate and require no calibration. This type of level sensor is also non-invasive because it does not have to touch the product that it is sensing. The disadvantages of radar sensors are that they are expensive, as well as have a limited detection range. If we go back to our shingle manufacturing plant example, a radar level sensor could be an ideal solution. Much like the ultrasonic sensor, radar sensors are ideal for hot liquid storage tanks.